So the next one is electronic configuration of D block elements and the transition elements. So D block elements electronic configuration NS122 N-1 D 1 to 10. So it is the penultimate shell N-1 D. N-1 D is the penultimate shell. It is the penultimate shell. So that is the N-1. Actually D block elements n values start from what is 4. D block elements n values from what is 4. N values from 4. N value 4 it is 3D. N value 5 it is 4D, like that. Now transition elements general electronic configuration NS122 N-1 D 1 to 9. It is completely filled, it is the partially filled, incomplete filled. That is the difference. So what is third B2, what is third B2, third B group to 1B group. These elements are considered as transition elements. Third B group to 1B and 2B considered as D block elements. Okay. Now in these D block elements 3D, 4D, 5D series, some elements with exceptional electronic configuration, that is the anomalous electronic configuration. For stability, why these elements are show the anomalous electronic configuration? For stability, the element stable with D block elements stable with D5 configuration, it is a half fill configuration. D10 configuration, it is completely filled configuration, is stable. So the D block elements with half fill configuration D5, complete fill configuration D10 with stable. So for stability, one electron transition from S to D. So these elements show the anomalous electronic configuration. The elements are 3D series elements. So chromium 24, copper 29. So chromium 24 electronic configuration, argon 18, 4s1 5d5. Actually it is 4s2 3d4, 4s2 3d4. But stability, one electron transition from S to D. So then it is half filled stable. Same as copper 29, argon 18, 4s1 3d10, 18 plus 1 19 plus 10 29. So now 4D series elements, what are? Molybdenum MO atomic number 48, palladium atomic number 46, silver atomic number 47. These three are exceptional electronic configurations. Molybdenum 42, it is the krypton 36 plus 1 37, 37 plus 5 42. So it is krypton 36 plus 0, 36 plus 10 46. So then krypton 36 plus 1 37, 37 plus 10 47. So next 5D series elements with anomalous electronic configuration, platinum 78, Rm it is gold 79. So krypton 54 plus 4f14, 68 plus 1 69, 69 plus 9 78. So it is 79. Xenon 54 plus 14 68, 69 and 10 79. So these how many elements? 1 2 3 4 5 6 7. 7 elements with anomalous or exceptional. What is exceptional electronic configuration? Anomalous or exceptional electronic configuration. So it is the configuration. Now occurrence of the D block elements. Occurrence means availability. Actually comparatively 4D and 5D series elements, 3D series elements are largely available in the earth crust as well as nature. So 3D elements availability occurrence is greater than 4D and 5D series elements. Now another important or interested property is present in 3D series elements. 3D series elements. What are 3D series elements? Atomic number from 21 to what is 30. 21 to 30. In these numbers, 3D series elements with even number. what is a even number, that is 22, 24, 26, 28, 30. So these are available largely comparatively odd number. What are odd number? 21, 23, 25, like that. Especially in 3D series, even atomic number elements are available largely comparatively odd atomic numbers. Odd atomic numbers. So generally, D block elements or transition elements are available in the form of minerals. What is in the form of minerals? So then iron mineral, important iron. What is iron? Fe. Important iron mineral is hematite. That is a hematite. It is the Fe2O3. Hematite is the Fe2O3. So next one is manganese minerals. Manganese. What is a manganese? Mn. So these two are the manganese minerals. One is pyrolusite. It is a MnO2. Next one is magnetite. Not magnetite. Magnetite is the mineral of iron. It is a magnetite. So its composition is Mn2O3H2O. So next one, chromium mineral is the chromite. Chromium mineral is chromite. Chromite is the mineral of chromium. So its composition is FeO and Cr2O3. What is a Cr2O3? Okay. So now these are the minerals of the some deep and transition elements. So next one is important point is actually in the D block elements or transition elements, 1b group elements. What are 1b group elements? That is copper, silver and iron. These three elements are considered as coinage elements. It means by the using of these three elements to manufacture or prepare the coins. So these three elements, what are copper, silver Ag and Rm, is known as coinage elements. So these are belong to 1b group. What is a 1b group? So it is a 3D series, it is a 4D series, it is the 5D series. Okay. So its atomic number 29, its atomic number is 47, its atomic number is 79. So now these are the occurrence and the minerals of the transition elements or D block elements. So now next one is the properties of the transition elements. So transition elements show the many number of properties. Many number of properties due to transition and D block elements outer electronic configuration is partially filled. What is partially filled? So its chemical reactivity is more. So now next one is properties of, what is properties of transition elements. Properties of transition elements. What is the properties of transition elements? So now what are the properties of the transition elements? Mainly it is the what are metallic nature. Number one is metallic. What is a metallic nature and electropositivity. What is electropositivity? What is a electropositivity and metallic nature? So now second one is what is high melting and boiling points. High melting points and boiling points. So next one is actually transition elements are extremely hard. What is it? These are the extremely hard. These are the extremely hard elements. So now fourth one is D block elements show the variable oxidation numbers. What is a variable oxidation numbers? Variable oxidation numbers. So fifth one is D transition elements are good conductors of heat and electricity. So then these are the good conductors. What is a good conductors of heat and electricity. What is good conductors of heat and electricity? So next one is its magnetic nature is what is paramagnetic and ferromagnetic. So these elements show the paramagnetic and ferromagnetic nature. Ferromagnetic nature. So next one is formation of alloys. What is formation of? What is formation of alloys? So alloys means a mixture of metal and metal with non-metals. So next one is transition elements formation to form the complex compounds. Formation of complex compounds. Formation of complex compound. Then next one, formation of hydrated color ions. Formation of hydrated color ions. That is formation of hydrated color ions. And the transition elements to gives the interstitial compounds. What are interstitial compounds? Okay, so these are all the properties of the transition elements. What are the transition elements properties? Metallic nature and electropositivity, high melting and boiling points, extremely hard. So now variable oxidation numbers, good conductors of heat and electricity, and paramagnetic and ferromagnetic in nature, formation of alloys, next formation of complex compounds, next one formation of hydrated color ions, next one formation of interstitial compounds, and also most of the D block or transition elements act as catalyst. So now it is the catalytic property. What is catalytic property? So these are all the properties of transition elements. What are transition elements? So then before explanation of the properties of transition elements with some periodic properties. What are periodic properties? What are the mainly periodic properties? Atomic size, ionization potential, electropositivity, electronegativity, electron gain enthalpy, or electron affinity, or electrode potential values are explained. So then it is the properties of transition elements.